Hey guys, I know I was missed, but I'm back again. Welcome back to Mr. Leaf Math. Alright, so this is a continuation from our previous video, alright, which we were doing fractions. So last time we learned about the foundations of fractions, understanding how to represent fractions, or the types of fractions, know that it's mixed number, not mixed fraction. So today we'll be basically focusing on the calculation aspect of it. Alright, which basically involves converting mixed number to improper fraction and converting improper fraction to mixed number. Alright, so let's get right into it. Alright, so to begin, if you remember, a mixed number basically involves a whole number and a proper fraction. Alright, when we're converting a mixed number to an improper fraction, there are two things that we basically do. Alright, or two operations, two calculations. Alright, the first one involves multiplying our whole number. Remember, the whole number is big on that, you see what here. Alright, multiply the whole number by the denominator of the proper fraction. So multiply the whole number by the denominator of the proper fraction. Alright, so this whole number that we have right here, this whole number that we have right here, we multiply it by the denominator of the proper fraction. And you see that result that we get, we're going to add that value to our numerator. So those are the two operations that we really need to know. Alright, multiply the whole number by the denominator of the proper fraction, and then the result, we add it to the numerator. So let's look how it goes now. If we say 2 multiplied by 4, we get 8, right? We're not going to write down 8, what we're going to do is that we're going to take that 8 and we're going to add it to the numerator we have up here. Alright, so 8 plus 1, that'll give us what? 9. So that's going to be our numerator for our fraction. Denominator is just the same denominator we see right here. So answer it? A 9 over 4. Alright, again, you take the whole number, you multiply by the denominator of the fraction. Then you add that result to the numerator, and that will give you your answer. Do the same thing for this one. We're gonna multiply our whole number by our denominator, then we're gonna add our result to our numerator up here. Alright, so 3 times 5, that's 15. 15 plus 4, that's how much? 19. So that's gonna give us a 19. And what's gonna happen for our denominator? Same number we have now here. See that? Same number. For this one, it means the same. 1 multiplied by 7, that's 7. 1 times any number is itself. So 1 times 7 is 7, plus 1 up at top. That's going to give us what? 8. 8 over the same number that we say right here, 7. The denominator always come back. Same thing for this. 2 multiplied by 12 is going to give us what? 24. 24. And then if we add 7 to 24, how much are we going to get? 7 to 24. So 24, 25, 26, 27, 28, 29, 30, 31. 31. Calculator can calculate that. So 31 over a 12. Alright, continue again. 4 times 3, that's how much? 12. 12 plus 2 is how much? 14. So that's going to be a 14 over 3. Cool. The last one is 5 times 8 plus 7. So 5 times 8 is how much? 40. 40 plus 7 is 47 over or 8 that we have right here. So that is us converting a mixed number to improper fractions. Again, basic theory that you need to understand. You multiply your whole number by the denominator of the fraction. Two parts of a mixed number, a fraction, a whole number, and a proper fraction. So multiply the 2 times the 4, then we add the numerator. And there's a case for all of these. 3 times 5 plus 4, 1 times 7 plus 1, 5 times 8 plus 7, 4 times 3 plus 2, 2 plus 2 times 12 plus 7. And those give us the numerator for each one of these fractions that we have. The denominator comes now wherever we see, or whatever we see, as our denominator of our original thing we have right here. So the proper fraction of our mixed number. And that's the basic theory with converting mixed numbers to improper fraction. Alright, so let's get into doing the reverse now. So converting improper fractions to mixed number. Alright, so there are many ways we can do this. Alright, and I'm going to do both, which is basically just raw calculations using a calculator, all of that, while I'm going to do demonstrations. Alright, so let's start off with the demonstration because I like to diagram. So what I'm going to do is that I'm going to draw 21 circles. So whatever number is in the numerator, I'm going to represent that as a pictorial diagram. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Alright, so I've just drew 21 circles. Alright, with every fraction, proper or improper, if you want to well, not proper or improper, but improper fraction specifically, if you want to convert, it's a matter of how many times the denominator can be divided into the numerator. Alright, so it's how many times our denominator can be divided into the numerator. That will give us our whole number. Whole number. All of these whole numbers. So that is telling you basically that 5 goes into 19 3 times, 4 going to 9 2 times, 7 going to 8 1 times, 8 going to 47 5 times, 3 going to 14 4 times, 12 going to 31 2 times. So that's the whole number aspect of it. Alright? So the same exact approach for each one of these we'll have right here. So same exact approach. Alright? So that basically tells us the whole number part. The numerator now. The numerator now is basically what remains after we divide the denominator into the numerator. What remains. That's what comes at the top of here. So denominator, always the same as each denominator you see right here. So always the same as that. Alright? So again, when we are converting improper to mixed number, the whole number basically is how much time the denominator can go into the numerator. The numerator of our proper fraction is basically what remains after we divide it into it. The denominator is always the denominator of the improper fraction that's already there. Alright? So let's do that. So as I said, I've drawn some circles to represent our 21. So let's see how much 4s we can get out of it. Alright? So there's a 1 group of 4. It's a 2 group of 4, 3 groups of 4, 4 groups of 4, 5 groups of 4. So that is telling us that we just get 5 groups of 4. So that means that 4 can go into 21 5 times. Alright? What remains, see it here by itself? That remains. So that is a 1. And again, for the denominator, always come back to itself. You get it? Again, whole number is always how much time the denominator can go into our numerator. Numerator of our proper fraction is always what remains. Denominator, always the same as what's there. So the denominator of our proper fraction is the same as the denominator of our improper fraction. Cool. We use a pictorial diagram which we draw the amount in the numerator. Highlighted the groups of 4s. 1, 2, 3, 4, 5 of them. 5 times we can get out of it. So 5 groups of 4s we can get out of it, which leaves us with a single one. I will put that back over the denominator. If you're using a calculator, all you would have to do is that you're going to divide the 4 into the 21. Alright? What happens when you divide the 4 to the 21? You're going to get 5 point something. Alright? So that 5 point something basically tells you that there are 5 exact groups, you know. Alright? And the point basically tells you that you can't get the exact next group out of it. But you need the exact, which is this. The 5. To determine what remains, just multiply the 5 back by the 4. So they multiply the 5 by the 4, they get 20. But how much do I go to? I go to 21. So how much more we need? We only need 1 more. So there's 1 more that remains. You put that up over the denominator. Again, just divide the 4, the denominator, into the numerator. Whatever answer you get, which is the 5, that would tell you the whole number. Multiply the 5 by the 4 to see how much exactly that add up to. If we add up all of them here, 20 add up to. And 5 times 4, it is 20. Alright? But our average is 21, so we need 1 more in order for each 21, don't it? That 1 more come for the top of here, so. Over 4. Same thing for this one. So I'm supposed to draw the 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there? So we're supposed to highlight the groups of 5 now. 1, 2, 3, 4, 5. So it's a 1 group of 5, 2 groups of 5. Alright? 1, 2, 3, 4. So we can't get to our next group of 5 out of it. Alright? This is basically telling us that we have 2 groups of 5. 2 groups of 5. And how much remains? 1, 2, 3, 4. 4 remains. And what's the denominator for this? A 5. So then, again, we want to do the calculation route with the calculator. 5 into 14 goes 2 times. So you get 2 point something. Alright? So 5 into 14 goes 2 times. Alright? Multiply 2 times 5 now would I get 10. Because that would represent 10 out of the 14. Almost left back, 4 of them. Because 10 plus 4 would I go to 14. Alright? 4 back over the same number. Same thing for this over here, so. If we never dare do this, so let's do it. Let's figure it out like this first, then we get back to this. Alright? So that's an 8 into 23. So if we divide 8 into 23, we basically get 2, don't it? Because 2 times 8 would give you how much? That would give you 16. Alright? So that would give you 16 right there. So we know so that's 2. 2. 16, but we have got 23. So 16, 17, 18, 19, 20, 21, 22, 23. How much that? 7 more that would I need. Put it back over your 8. Again, 8 into 23, 2 times. 2 times 8 how much? 16. So that covers 16 out of the 23. How much more we need for 16 to get 23? 16, 17, 18, 19, 20, 21, 22, 23. So that's 7 more minutes. See here? 7 over 8. Alright? So that leaves us, if we're supposed to draw the diagram, or draw to represent it, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Alright, so let's get out our groups of 8 now. One group of 8, that's all. 1, 2, 3, 4, 5, 6, 7, 8. 2 groups of 8. 1, 2, 3, 4, 5, 6, 7. So that's one group of 8. So 2 groups of 8. 1, 2, 3, 4, 5, 6, 7 remains. Back out of 8 as the denominator. Alright? We'll get larger numbers which we might not have the time to draw the diagrams to represent them. Alright? So we have to do the calculation method. So what we would have done is that we would have said 15 into 94. And 15 into 94 goes how much time? 6 times. Alright? So that goes 6 times. And that would have given us a 90. 15 times 6, 90. Alright? How much remains? We would need 4 more. Cool? Denominator come back. If you don't have a calculator, try counting by 15. 15, 30, 45, 60, 75, 90. 6 groups. Good? That's why I have 6 right so. How much remain? 4. Because 90 plus 4 would give us 94 out of the 15. Do the same thing in a case like this. So when I would say, alright, 20 into 117. Cool? Majority of us know that 20 goes into 100 5 times. 20, 40, 60, 80, 100. Cool? 20, that would leave us at 17 and 20 can go to 17. Alright? So that basically will give us a 5. That basically will give us a 5. Give us a 5. I would know that there are 17 remaining. 5 times 20 would give us 100 down. So 17 remaining. Back over the 20. Cool? Again, calculator can tell you. 117 divided by 20 would give you 5 point something. You take the 5, you multiply by 20, that give you 100. Then subtract that 100 from the 117 and that would tell you how much remains. Cool? Back over the same number that's there. You do the same exact thing for the 25. Alright? 25 into 79 goes 3 times. 3 times 25 would give us 75. Alright? So 3, and if 75, how much more we need to go to 79? 4 more, don't it? That would give us a 4 over 25. So again, what you do is that you divide, see how much times your denominator can go into our numerator. Alright? That will give us a whole number. Cool? You want to know how much this 3 group of 25, how much it represents. So you multiply 3 times the 25, that would give 75. How much more we need on 75? Forget the 79. 4 more that come at the top. The denominator remains the same. This represents how much groups of 25 can go into this. This represents how much remains. This represents our same denominator. Alright? So again, a brief overview. Converting mixed number to improper fraction. We multiply our whole number by our denominator. Then we add our numerator to the value that we get to multiply these two. 2 times 4, that's 8. Plus 1, 9. Over 4. 3 times 5, 15. Plus 4, 19. Over 5. 1 times 7, 7. Well, 1 times 7, 7. Plus 1, 8. 7 comes up. 2 times 12, that's 24, 24, and 7. 31 over 12. 4 times 3, that's how much? 12, 12 plus 2, 14 over 3. 5 times 8, that's 40, 40 plus 7, 47 over 8. Same thing, we're going to do the improper now to mixed number. It's basically the reverse of it. Alright, so you see like this times this would have basically given one value and add. For this case now, you say how much time can the 4 be divided into the 21? That's 5 times. And this 5 over 4 represents 20. So that means that we need 1 more to make the 21. So the remainder compares plus the 4. So if you realize that you're supposed to be change back now, that's 5 times 4, which is 20 plus 1, 21 over 4. See? You see how much? Same thing over here. So 5 into 14, 2 times. How much remain? 4 over the 5. 8 into 23 goes 2 times because that's 16. How much remain? 7 over 8. Alright? Same thing at so 15 into 94, 6 times. 6 times 15, that's a 90. And then if you're supposed to add now, let's say you need 4 more over the 15. Same thing right here, so 20 to 117, 5 times, 17 remain, put back over the same denominator. 25 to 75, 3 times. How much remain? 4 over 25. And that's it. Like, share, subscribe.